So we'll start today with correlation graph, plot iris. So when you do plot iris, it plots the entire, each of the elements of the data frame, it plots against each other. Okay, and it gives you an idea of the correlation among its variables. And we have seen how to do this in Rattle also in a more visually attractive way. But we've done this last time, where we can plot each variable but by a particular group, by a particular category. So we are plotting sepal length here, but for each species. So it does a scatter plot, but it groups it for each species and does. So since the sepal lengths for each species are very different from the sepal length from another species, your plot looks like this. Box plot. Yeah, and this gives you an idea of the distribution. We have covered this. But so there are 5 basic points in a box plot which at one glance we are able to see. The minimum value, the maximum value, which are the 2 extreme ends of the plot given by the 2 horizontal lines. Then you have the box in the middle, which has the first quartile, the third quartile, and the median. So here what we had just done, it is plotted one variable, not even against another variable. So the x-axis becomes the index. Okay, so it just keeps plotting the values of each sepal length one after the other. Right? So if I just say plot MPG, just plots all the values of the MPG. That's what they have done here. Okay. What is a stem and leaf plot? It's a kind of binning. Okay. Let's say I have a vector. I've just defined this vector of how many? 11 variables here. And then I just call a stem x. So what it does is all the unit numbers. What are the unit numbers? 3, 7, right? So this group, it's a kind of binning. So there is a number called, wait, see now it is very simple, but I'm just trying to understand why. So 3 is 1, 7 is 1, but I don't get why is they putting 12 here. See, a normal stem and leaf plot is what you see here, what I'm showing you on the screen. So 15 and 16 it puts into 1. So all the 10s and 20s it sort of divides, you know, and it just groups it. It's kind of a binning. So here what they have is 15, 16, 21, 23, 23 like that. So 15 and 16 are in the 10s bucket. So the stem is 1 and the leaf is 5 and 6. So right from 21 to 26, all these 5 values are in the 20s bucket. So your stem is 2 and these are your leaves, 5 leaves there. So in 30s bucket there is 2, so there are 2 leaves, and similarly with 41. So I'm just trying to figure out how they have divided it here. Scale 10, No, shouldn't be scale 10. See, the 3 and 7 it is putting is fine. I don't see, maybe 12 also it is putting in the same bucket because it has not created a bucket for 1. So 3, 7, 12, and I don't, is that 14 ka 4? It's a little funny this plot is. Yeah, 14 I think it's 1, 2, 1, 4. I'm thinking. Between the 20s and 30s I have 23, 22. I'm not sure. I think it's a little different way they are doing the binning. $24. Where do you see 24? Shift. There is 23. There is 22. So see, the 24 will, there is no 24. So there is 2 which is out, which is your bin, second bin. And 23, for 23 you just put 3. For 22 you just put 2. But I'm thinking why? But it is not there in the list, no? 24. Yes, you are right. It's not there in the list. In general, you've understood what is the principle. When you have a short set of data, like if you have 10 or 20 data sets, it's difficult. Even if you do a bar plot, you don't get an idea of the distribution very well. So a stem and leaf plot gives you a idea of the distribution from that respect, creating the bins. But here it's doing it in a slightly different manner. So I'll really have to get back to you on what is the scale 2? Let's come back to stem and leaf plot once we have covered the other things. Okay. So basic plots, again, this we have already plotted, let's say sepal length. But when we do just plot iris $sepal dot length, it does just a line, just a dot plot. But if you want it to be a line plot, then you just have to give type is equal to L. And I'm sure you know this already. That's what they have done here. So this is usually a time series. When we do a time series plot, we give lines because it gives you a sense of a trend. Line gives you a connection between the points. So it sort of makes you feel that things are changing in this way over time. When we are doing sepal length, it makes more sense to just do a dot plot because it's not really connected. It's not like these dots are changing, right? So these are some of the visualization concepts that when it's a time, when a variable is changing over time, line gives you the impression of that, of a value changing with respect to time. Then you use a line plot for time series. It's more common than using plotting individual values. Okay, this is your kind of an histogram. Looks very similar. It's a bar plot. And we know that we don't really want to see the pie chart too often. Pie is not the best way of visualization. But if you want to do it, there's a pie command in R, but you need to make a table for the, so there's a table command. If you just do table we have seen this once, you may recall that it all tells you for the whole iris data, if you table it by a particular categorical variable, it just tells you how many fall in that one category. So if you, for example, for cars, you could table by cylinder. Yeah, and then you could do a pi of this value. So it will tell you how many cars in your cars data set have 4 cylinders, how many have 6 cylinders, and how many have 8 cylinders. Again, as I said, it's difficult to compare the portions in a pie chart, and if I had made a bar plot, I think I would be able to see the comparative difference between, let's say, the number of cylinders, number of cars which are 4 and 6, more than a pie chart. So if I had done, let's say, a bar plot of this table, see what happens. Yeah. So here, isn't it visually easier to find out how different they are from each other than in a pie chart? That's exactly what we mean when we say pie should not be used too often. Histogram we have seen. Where do you use histogram and where do you use bar? Okay, histogram you use, it's like a frequency distribution. You know, when we are using a frequency distribution, we see the only difference between histogram and a bar is that in histogram the thing is connected to each other. There's no gap between the two columns. Whereas in a bar graph, there is a gap between the two columns. So when they are discrete, often if there is a range, you know, like 0 to 10, then 10 to 20, then a histogram. When there is binning, histogram is more useful, and especially for a frequency distribution, it gives you a sense of the overall distribution. For discrete values which are not really connected to each other in a continuous manner, there you can use a bar graph. So if you have 3 categories, like, you know, the setosa and like what I just did, yeah, this one. These are 3 groups of cards which have different number of cylinders. Would you use a histogram here? Not really, because they are disconnected. So you will use a bar graph, right? But if you do a frequency distribution, then you can use a histogram, because then it is continuous. Yeah. So for example, here they have plotted the density, but this is like histogram is a frequency distribution in a discrete sense, and this is a frequency distribution of a continuous variable. So this, if you just plot the density, it just it gives you a continuous plot which gives you a sense of the probability distribution of sepal length. Box plot we have covered. So you see what this rug does? Rug just gives you a scale. So a normal box plot will not give you these this whole scale. So when you use this rug command, it gives you a scale on the left. So Andrew, did I answer your question? Great. So this is okay. These are some things which you can do in R, where see every time I give a plot, it creates that graph, and you are no longer able to see the previous graph. Though in R Studio you can go back to the previous graph by just this arrow. But let's say I want to see all the graphs in one screen in order to evaluate, in order to evaluate all the graphs together. So if you want to do that, then there's something called this par command, which just divides the whole screen space into the matrix which you mentioned. So here they have given par mf row 3, 2, means 3 rows and 2 columns. So they have divided the whole screen into 3 rows and 2 columns. And then if you keep on plotting these 6 plots which they have done here, it will plot it in each of those cells. Okay, so if you want, we can do that, but you can try it yourself also. Once you have done that, let's say I want to do plot pi. It comes in one part. I'm going to mix up my empty cars data with iris data. Hope that doesn't matter. I don't want to. So you see what this does? It just takes a part of it and so like this, it will give you all 6 plots. Okay, I'm not doing the whole thing, but you can, sorry, if you give the whole data set, then it could have given some other plots. Fine, you get the idea. Can we do multiple plots in one XY coordinate? I was just showing that, oh, you mean the same coordinate, dual axis? Yes, you can do that, but off the top of my head, I don't remember the command on how you do that. But yes, there is a way to do that. Just shoot me an email, Sushant, I'll reply back to it. I have to find out. See, normally when I do a lot of visualizations, I use Tableau. And these things are very easily done in Tableau. In R, this is my personal, how I use it. R I use for more of data mining and data analytics than for visualization. I just use R visualization for exploratory analysis. So when I have data, then I just want to see what is the distribution, box plot, histogram. Then I use R, and not a lot of advanced graphical techniques in R I don't use, though I know that R has that. So I just have to look up. But these things can be done very easily in Tableau. So if you are really interested in, visualization, I would encourage you to get a copy of, or maybe a licensed version of Tableau, and take a crack at it. And if you are interested, I can even show you a little bit of Tableau to get you started. So if you're interested, just let me know. It will be digressing a little bit from the R class, but I think it has value. So we can just take a few minutes and, maybe 10 minutes and do an introduction to Tableau kind of a thing. So you all let me know if you feel you're interested in it, then we can do that. Okay. Sunflower plot. When there is a lot of data, if you do a sunflower plot, it just plots small values for all the plots and gives you the exact picture of how the data is distributed. Unlike in histogram or something where it will try to group it. So it's often it leads to overplotting. You know what is overplotting, right? When you are trying to plot a curve over each and every point. Yeah. There's absolutely zero smoothing. This is just telling you how you can give your give a label to the x-axis and label to the y-axis, and we have covered this, giving a title by the main parameter, giving X label as X lab and Y label as Y lab. Okay, this is another way of setting the background color. Somebody had a question at the beginning of the class. So you can just say, before you do your plot, you can just give this command, VG equal to yellow in this case, which is not looking very nice. So R has a lot of built-in color schemes. So if you see these color equal to, of course you can write color equal to red, blue, yellow, green like that. But let's say you want your histogram to have a kind of a heat map, right? Heat map means when something has high values, it has got a higher intensity. When it's got a lesser value, it's got a lower intensity. So the first command here, where you're doing a histogram of some depths, you are saying that I want heat map, and you're passing a parameter 7. Okay, so parameter 7 or heat color 7 is probably just it's a kind of a heat map scheme. So it is a red, blue, red, orange, yellow kind of a color scheme. So where the highest intensity red will be for the some values, and then for a lesser intensity will be for lesser values. So there are different ways by which you can mention your intensity, and this just shows you different color schemes for heat maps, for terrain colors. So when you do rainbow, it's all different colors, red, blue, yellow, green, orange, yeah, this is the last one. Whereas when you see heat maps, then it is the same, it's a particular color scheme. And similarly, you have topo colors and terrain colors, so you can experiment with colors. Sushant, I didn't get your question. Graph plot for aggregate values as in? If you could give me an example. Okay, do that. You may have to do a little data manipulation, summing of the data, etc. before you do the plot. Not sure whether you can do it directly, but send me the email with the data set and revert. Sushant, you sent me a mail yesterday, right? Did that work? Did you try that? If error command in Excel? Okay, try that and let me know. Okay. So this is another, we are still working on color palettes, using color palettes in R. So just like you can use, this color brewer library gives you a higher range of colors. So a lot of color sets you can use. Like you see, you can say greens and grays and whatnot. See, this is another kind of advanced binning. So, and a kind of a plot of the distribution. So there is a library called hexbin which you can load, and what it does is, if you see, it is for each of the species, it is plotting the sepal length, and it is showing you in each bin, like for each value of sepal length, let's say for 5 sepal length 5 has how many flower or how many samples. So that shade will tell you. So by one shot, by looking at the shade, you can see where are the highest, what are the highest numbers, where are the concentrations, right? So you have the legend on the right, count. So if you have a very high intensity, it means a high count, right? So let's say the blackest point in your first species comes to something a little over 5, right? So you can see that that has the maximum number of flowers of that species have a sepal length of around 5 plus something. So it gives you a sense of the distribution along with the binning. That is hex bin. Yeah. So when you have many data points around a certain range, yeah, if you do a scatter plot, it will look very cluttered. It will not give you a clear idea of the distribution. There hex bin comes in useful, and because it puts all the data points within a certain small range into one bucket and gives the color to that. That addresses the problem of overplotting and gives you a nice representation of the distribution. Yeah, similarly there is something called a table plot, for which there is a library called tab plot, and again it gives you a visual summary of a data set. And what are we doing here? For each of the 4 values, so you have a sepal length, width, petal length and petal width, and you have the 3 species. So forget about the species part for now. You see the distribution of sepal length, sepal width, petal length and petal width in the 4 columns. Yeah. So, and it's a kind of a cumulative distribution. Hold on, it's not a cumulative distribution. I correct myself. It is a frequency distribution. So for sepal length, let's say greater than 6, or let's say close to 7, you have that many percentage of flowers which have that sepal, right? So for sepal width, let's say the highest thing is around 55. So you have a let's say 4.5. So 4.5 sepal length, 55% of the flowers have. Now out of this 55% of the flowers, this species distribution tells you how much is setosa, how much is versicolor and how much is virginica. Kind of, right? So you can get a sense. So if you go on the top part, you see that there are very high sepal length, high petal sepal width, reasonably high petal length and petal width. And all these follow in the virginica flower because they are all this yellow color or yellow ochre color. Similarly, at the bottom part of the graph, with the smallest petal lengths and the petal widths probably belong to the setosa flower. So these are the kind of inferences you can draw by looking at a table plot very easily. This is a table plot of our empty cards. So you've understood what is a table plot, and there is a tab plot for that. There is so these are the libraries which we use, tab plot, ggplot, and here they have used a table plot of some diamonds data based on different features of the diamond data, which is like the carats and the cut and the color and the clarity, etc. Okay, so this is a mosaic plot, and this is also an advanced graph which gives you an idea of the distribution across different dimensions. Okay, so here let's say they have a group of some individuals, and these individuals have different parameters like whether they are male or female, whether they have what color of their eyes and the color of their hair. So what they have done here is for each of the so you see these boxes, they sort of showing how the people are distributed among these different parameters. at one shot you can see that, where are the major chunks where people are, of data, etc. So let's say hair color brown most people have brown hair than, let's say, black or red or blonde, something like that. And males with red hair are like really less. But among the males who have red hair, which is really less, most of them have brown eyes, So these kind of inferences you can make. So for detail going in depth, these are not useful. But to give you an overview of the distribution of the data, these are quite useful.